Hello, welcome to Candent Technologies, Navy, STP, Syscom Technical Information Exchange, 2026 presentation. Today, we will be talking about our multifunctional heat exchanger for aerodynamic aircraft inlets, a Navy STTR Phase 2 program sponsored by NavAir and NAWCAD. As we begin, please allow me to give you a very brief introduction to Candent Technologies. We are a small engineering research and development company established in 2001 in the Indianapolis metro area and very recently acquired by Bascom Hunter Technologies. Our primary focus is on propulsion and power systems for airborne, marine, and ground vehicles. Our capabilities and technology portfolio are quite broad and beyond the focus of this STTR. They include clean sheet design, build, and test of advanced technology, small, high efficiency, high power density, turboshaft turbine engine prototypes for propulsion and power generation, extremely low acoustic signature, high efficiency outboard motors and thrusters for special forces, small boats, compact exhaust waste heat recovery systems for megawatt-size marine and land-based gas turbines and diesels, and several other technologies and capabilities that we would gladly tell you about. Now, let's talk about this STTR and the solicitation requirements that we are addressing in the program. We must design, optimize, using multi-objective optimization integrated with multi-physics analysis, develop, build, and test a high-capacity, high-effectiveness, lightweight heat exchanger compatible with aircraft aerodynamic engine inlets and able to dissipate very large amounts of waste heat from onboard aircraft systems. Our multi-physics analysis currently indicates that our design performance will better the program requirements, and we will soon be conducting wind tunnel aero and thermodynamic testing to confirm the results of our design analysis. The miniaturization of electronic components has resulted in extraordinary growth in combat aircraft capabilities since the size of the systems is now small and enables much more functionality, which has been incorporated in the aircraft, resulting, however, in a corresponding substantial rise in waste heat generated by the onboard aircraft systems, creating an increasingly urgent need for improved thermal management systems capable of dissipating the growing amount of waste heat generated on board. Because conventional solutions have space limitations that constrain electronic system installation on densely packed airframes, such as fighter aircraft, new approaches are needed, and a heat exchanger using the large airflow typical of modern turbine engines as a heat sink can dissipate enormous amount of waste heat, which is the reason why this technology, when optimized, offers the best solution. NAWCAD, the sponsor of this STTR project, reached the conclusion that an optimized heat exchanger located in the aircraft aerodynamic inlet and using the large engine inlet airflow as the heat sink would be the best technology solution, and that is why they made such technology the focus of their solicitation. Because of the multiple physical characteristics of the problem, such as pressure loss, inlet flow distortion, foreign object debris resistance, etc., Candent and their academic partner have developed design and optimization tools, which incorporate multi-objective algorithms integrated with multi-physics analysis and computer-aided design tools, to quickly develop and optimize fully compliant heat exchanger designs into a small subset from which the best configuration is chosen for the particular aircraft integration requirements and flight conditions/mission profiles. Our current Phase 2 base efforts have advanced multi-objective optimization and integration with multi-physics analysis and CAD generation. The final heat exchanger configuration is now in progress, and the wind tunnel and thermodynamic test plan and test rig hardware design are in progress. Prototype test hardware procurement and fabrication will start soon after, shortly followed by prototype assembly, bench testing, and system testing, which will continue through the Phase 2 option of the program with design updates based on test results and refreshed, modified hardware. We expect to advance the technology through TRL6 by the completion of the STTR program. To recap, the design objectives and characteristics of the system, as shown in the slide, have advantages and benefits made possible by the design optimization process used by Candent, resulting in such swap characteristics that enable the dissipation of considerably larger amounts of waste heat from the onboard aircraft electronic systems, allowing for a substantial increase in aircraft electronic fire control, radar, communications and navigation, and other electronic warfare systems, as well as directed energy weapons. Furthermore, the design also is intended to minimize the low observable characteristic of the aircraft engine inlet, and the scalability and versatility of the inlet heat exchanger design makes it easily and readily available for many airborne platforms of various types, both manned and unmanned. At this time, no program of record or specific weapon system has been identified as the target of this technology. However, the technology is compatible with many current fleet aircraft, and its versatility will ensure compatibility with near-future aircraft applications, possibly an unmanned aircraft with heavy electronic system concentration and high heat rejection, or updated versions of current and near-term advanced manned fighter aircraft. Moreover, the system is also well suited for use on aircraft electronic or directed energy weapon pod systems equipped with self-contained turbo generators or other high airflow internal combustion prime power sources. Notwithstanding the absence of a specific transition target, the trend in military aircraft is for a rapidly expanding growth of onboard electronic and directed energy weapon systems, all of which will require a corresponding growth in heat rejection dissipation capability on board the aircraft. Hence, it is extremely likely that the development of this technology is timely. Candent, therefore, is maintaining awareness of developments with future aircraft designs, where the need for expanded heat rejection capability is most likely to arise. And the continued development of the technology is a strategic priority that will allow the company to launch specific variants for aircraft or compatible weapon systems in a timely response to the upcoming market demands. Following its strategic plan, Candent Technologies entered into negotiations with Bascom Hunter Technologies of Baton Rouge, Louisiana, resulting in an agreement whereby Bascom Hunter acquired Candent at the end of March 2025. The novation process for the government contracts is now in progress at the Defense Contracts Management Agency. Bascom Hunter, although still a small business, is a much larger enterprise than Candent, bringing to the table considerable financial, technical, managerial, and manufacturing expertise and resources, which will ensure continued development of Candent's current technology portfolio. Bascom Hunter has extensive experience with environmental control systems, heat exchangers, compressors, fans, motor drives, and controllers, all of which will bring great synergy to the Candent technology set. As we close our brief presentation, we thank you for taking the time to visit with us and invite you to come see us at the Navy STP Syscom Technical Information Exchange 2026. We have many technologies that may be potential solutions for other weapon system issues that you may have. And in addition, we also have extensive capabilities across many other technology disciplines, which could be key to developing solutions that you may be searching for now or that you may be anticipating in the near future.